So tactile fremitus is a part of the lung exam where you can quickly determine what the patient's baseline is and if their lungs are healthy or not. And so the basic premise is that you put the ulnar part of the hands on the patient's back and you ask the patient to say 99, and so that sound travels down their lungs and through their lungs into your hand. And so just a basic sketch of the premise is that the sound, for example, 99, would go down their lungs through the visceral part and the parietal part of the pleura and then into your hands. And so that can give you a quick exam of the lungs. And so, for example, in pneumonia, tactile fremitus is increased. Now, why would that be? Well, from baseline, what's different is the fact that there's now fluid in the lungs, which is never normal, right? Because you need air to be there so that it can diffuse across the membrane into your blood. So if you have fluid here, what ends up happening is that fluid is conducted better than air, and therefore the vibrations you feel will be actually loud, or it'll be increased, right, than baseline. So to explain why this happens, it's just a quick physics lesson. So when sound is just a simple disturbance, essentially, right? And so what happens is that energy goes, and air, all the particles are very far away. Liquid, all the particles are very close together. So when this disturbance happens, it goes and hits these particles, and since the distance between them is far away, it will quickly run out of energy quickly, just because if you bounce into this one, it takes longer for it to get to this one and longer for that, so the energy runs out, and so the distance will be low. Here, all the particles are very close together, so when the sound comes, it's very easy for the energy to be transferred and it'll go a farther distance. So that's why here, since it's on the inside, you have this fluid that will conduct the sound better, and it'll, because everything's so close together, and so it'll bump into each other, and therefore the energy will be conserved better, and therefore you'll feel a greater vibration when you place your hands on the patient's back. So moving on to the next example, when we have pleural effusion, we have to think about it a little bit differently. So once again, I said that sound is just a disturbance, right? So it doesn't have that much energy. So in this case, when the sound is going down, it amplifies it because it's directly contained in this cavity, right? This visceral pleura. And so it's amplified by the liquid because everything's so close together. See, the problem in here is when the sound goes down, well, what happens is the visceral pleura now absorbs that sound, right? It absorbs that sound, and the liquid in this case, right, because that's what a pleural effusion is, it's liquid in the pleural cavity between the parietal and visceral pleura. This now acts as a blockade of the sound. So it will actually impede the flow of the sound rather than facilitate it, like in this example. I know that's a little confusing, but just imagine that the sound is contained in the visceral. So since it's contained here, it's going to be amplified by a better medium. But in here, when it travels across the visceral pleura, it's going to be absorbed, and then after that, it's not going to travel as well because it's just extra area that it has to travel to get out. And so in this case, the liquid will act as a impediment to the sound instead of a facilitator. Same thing with the pneumothorax. It's also going to have decreased tactile fremitus, just like in pleural effusion, because the sound's contained in this area, in the visceral, and so when it's contained here, it's not going to be amplified because air is also a poor facilitator of sound, and so when it tries to travel, it can't because it's first absorbed by the visceral pleura, and then when it tries to go out, it has a harder time because now since there's air, once again, air is not a good conductor of sound, and so it will act as a further blockade of the sound. There's a good video covering this entire concept using cups as a model, and I think that'll be a good resource, so I'll link that in the bottom. So thank you for watching, and I hope that helped.